lesson, we're going to focus on solving rational equations. By solving rational equations, we have 3 steps. First, eliminate the denominator by multiplying both sides of the equation by its LCD. Second, simplify the equation. And third, check your solution. So let's start with our first example. 5 over 8 minus 3 over 5, and let's set that equal to x over 10. What do we need to do in order to find the value of x? What would you do? The best thing we can do is clear away all fractions. We have an 8, a 5, and a 10. What is the least common multiple of 8, 5, and 10? Well, we can make a list. Multiples of 5 are 5, 10, 15, and so forth. Multiples of 8 are 8, 16, 24, 32, and 40. Multiples of 10 are 10, 20, 30, and also include 40. So, 40 is the least common multiple. Let's multiply every fraction by 40. So what's 5 over 8 times 40? You can do 5 times 40, which is 200, and then divide 200 by 8, or you can do 40 divided by 8, which is 5 times the 5 on top, and that's going to be 25. Now, what about 3 over 5 of 40? 40 divided by 5 is 8. 8 times 3 is 24. And the last one, 40 divided by 10 is 4. 4 times x, that's 4x. 25 minus 24 is 1. And let's copy down the 4x. So both sides divided by 4. So x is equal to 1/4, so that's the answer.
We have 4x plus 6 over 5 equals 6x plus 3 over 7. We will use cross multiplication, so we have 7 4x plus 6 equals 5 6x plus 3, and then expand both sides, so we have 28x plus 42 equals 30x plus 15. Next, subtract 28 from both sides, so we have 42 equals 2x plus 15. Next, subtract 15 from both sides, we have 42 minus 15 equals 2x, and 27 equals 2x. Then divide both sides by 2. We have 27 over 2 equals 2x over 2. And then the final answer is x equals 27 over 2.
So, we're solving the rational equation. We have a given of 7x plus 12 over 4x plus 3 is equal to 2 over 5. First thing we need to do is get the LCD. And our LCD is 5 times 4x plus 3. And the next step is we're gonna copy the equation and multiply it both sides using the LCD. After that, we're gonna cancel out 4x plus 3 because 4x plus 3 divided by 4x plus 3 is 1. So we're gonna cancel it. And the remaining is 5 times 7x plus 12. And next the other side. 2 over 5 multiplied by 5 times 4x plus 3. Now we're gonna cancel 5 because 5 divided by 5 is 1. And we're gonna cancel it. So the remaining is 2 times 4x plus 3. The next step is multiplication. So 5 times 7x is 35x, and 5 times 12 is 60. And the other side is 2 times 4x is 8x, and 2 times 3 is 6. The next step is we're gonna take 35x and transfer positive 8, then it will become negative 8x. Next is we're gonna put down 6 and transfer positive 60, then it will become negative 60. And the next step is 35x minus 8x is 27x, and 6 minus 60 is negative 54. Next is 27x divided by 27. So what we're gonna do is cancel 27 and the remaining is x. And the other side is negative 54 divided by 27 is negative 2. So the value of our x is x equals negative 2. And that's it. That's how to solve the rational equation.
8 over 3x minus 2 is equals to 2 over x minus 1. We will use cross multiplication, so we have 8 times x minus 1 is equals to 2 times 3x minus 2. Then distribute. 8 times x is 8x. 8 times negative 1 is negative 8 is equals to 2 times 3x is 6x. 2 times negative 2 is negative 4. Combine like terms. 8x minus 6x is equals to 8 minus 4. 8x minus 6x is 2x. 8 minus 4 is equals to 4. To find x, we need to divide both sides by 2, so the answer is x equals 2.
6 over x minus 7 is equal to 9 over 2x minus 13. So we're going to use cross multiplication. So 6 times 2x minus 13 is equal to 9 times x minus 7. So let's distribute it. 6 times 2x is equal to 12x minus, 6 times negative 13 is equal to 78. Then 9 times x is equal to 9x. Then 9 times negative 7 is equal to negative 63. Then we're going to transpose the x variables in the constant. So 12x minus 9x is equal to negative 63 plus 78. Then we're going to combine the like terms. 12x minus 9x is equal to 3x. And negative 63 plus 78 is equal to 15. Then divide both terms by 3. So 15. So let's cross out the 3x and 3. So 15 over 15 divided by 3 is 5.
Okay, let's solve the rational inequality. 2x over x plus 1 is greater than or equal to 1. So first, we will do it. We need to make the right side 0. So what we will do is move the 1 to the left side. So we got 2x over x plus 1 minus 1 greater than or equal to 0. We need to make a single fraction on the left side. So what will we do? So let's take the LCD. To solve it, to the LCD is x plus 1. What we will do first, we will times the LCD, that x plus 1 is 2x over x plus 1. So we will cancel the x plus 1. We will leave 2x and then multiply it by x plus 1 because of negative 1. Negative 1 times x plus 1, that will become negative. X minus 1 over x plus 1 greater than or equal to 0. And then simplify, combine the similar term. So 2x minus x, that is x minus 1 over x plus 1 greater than or equal to 0. Let's just move the negative 1 to the right side. So the value of x is positive 1. In the denominator, x plus 1 is equal to 0. So just move the 1 to the right side, so our x is negative 1. Okay, so the 1 and negative 1 we will put on the number line. So on the number line, let's separate them. So the negative 1 should be on the left side, the positive 1 on the right side, according to the number line. Now, let's find out if 1 and negative 1 are part of the solution. How is that? This is just a substitute for the original inequality. So, let's see if we substitute positive 1, we will replace x with 1. So, 2 times 1, that is 2. And then 1 plus 1 is 2. So, 2 divided by 2 is greater than or equal to 1. Ibig sabihin, nag-satisfied yung 1. Therefore, the positive 1 is part of the solution. What we will do? Shade this positive 1. Ibig sabihin nun is part of the solution. Second, negative 1 when we substitute it here. When we immediately substitute it with the denominator. The denominator will become 0. It will become undefined. That means if it is undefined, it is not included in the solution. So this circle is still open. That is to say, don't shade the negative 1 because it is not part of the solution. We have 3 intervals. This one is in the middle. And this one, so here our intervals are negative infinity and negative 1. We will use open and close parentheses. In the middle, negative 1 and positive 1. We will use parentheses and bracket here. Here, positive 1 and positive infinity, we will use bracket and close parentheses. And next, we will do it, we will find out. Where is the interval part of the solution? How do we do that? Let's make a sign table. So here, we will put all the intervals. We will put this here in the middle. We will put there in the one on the right side here. Now, here at the test point, we will take only one for each interval. Okay, let's start with negative infinity and negative 1. And we will look at the one closest to negative 1. What is next to negative 1 is negative 2. Here in the middle of negative 1 and positive 1. And of course, what we will take is 0. So, we can evaluate it easily. And here in the positive 1 and positive infinity, we will also take the one closest to positive 1. So, positive 2. Okay, let's evaluate one by one. Here, first, let's put the numerator, that is x minus 1. Then the denominator is x plus 1. And then our final answer here. And then we'll substitute 1 negative 2. We'll substitute it with minus 1, that is negative 3. But we'll just put a sign. And here, negative 2 plus 1, that is also negative 1. Here, in the last part, we'll multiply the sign negative times negative. So, it become positive here. Then, we'll do it. Next to 0, we'll substitute 1 by 0 minus 1. That is negative. And then 0 plus 1, that is positive 1. So, the sign is positive. What we'll do is multiply the sign negative times positive. That is negative. So, the negative sign to. And the last, positive 2. 2 minus 1 is that positive 1. 2 plus 1, that is positive 3. So, they are both positive. Let's multiply positive times positive. That is positive. And so how do we get our answer? There, since it says greater than or equal to 0, means positive number. So what we will get is the positive ones, negative infinity, and negative 1. The interval, this is part of the solution, and the positive 1 and positive infinity is also part of the solution because they are the ones they were positive. Since this is included in the solution, here it is part of the solution. Using interval notation because we have an interval in the middle that is not included. How do we present? Okay, from negative infinity to negative 1, so we will use open and close parentheses since negative 1 is not included. So, parenthesis union of bracket because it is positive 1, it is included in the solution to positive infinity. That is our interval.